List of topic-wise video lessons already uploaded is available with me. A click will take you to the video. You need not search and waste your precious time. My email ID and phone number are in the description. In this tutorial, we shall see how one-way ANOVA problem can be solved in Excel. Excel is a powerful tool that allows users to conduct one-way ANOVA without the need for complex statistical software. With just a few clicks, you can perform the test, analyze results, and generate useful insights. This is the problem we are going to solve in Excel today. A study investigates the fuel efficiency kilometers per liter of 4 different car models. 4 cars of each model are tested. Model A 15, 16, 14, 17. Model B 18, 19, 17, 20. Model C 12, 13, 11, 14. Test the hypothesis that the mean fuel efficiency is the same for all the 3 car models at alpha equal to 0.05. Now open a new Excel file. Save it as per your convenience. Let me name the file as one-way ANOVA Excel. And save it on the desktop in the folder one-way ANOVA. Now it is time to enter the problem table values. You shall enter it in any cell you want which is convenient to you. Let me start it from C9. C9 is the cell address. 9 is the row identifier and C is the column identifier. As I have the table as a Word file, I shall copy it and paste by selecting the cell C9. Now you need Analysis tool pack to solve the problem in Excel. Normally it is there in Excel. Examine this first. Click the Data tab in the ribbon. Look for the Analysis tool pack at the top right corner of the ribbon. In our case, it is not there. Then we have to bring it here. How to do it? Click on the File tab. A new window opens. Go to the left bottom corner of the page. Select Options. In the Excel Options dialog box, go to the left bottom. There you can find Add-ins. Click Add-ins. The window opens a new page. At the bottom, by the side of the label with caption Manage, there is a drop-down text box with a downward facing arrow at its right. In the Manage text box, select Excel Add-ins. In our case, it is already displaying. Click Go. Excel opens add-in windows. You shall find a few add-ins available in the list box. Tick the checkbox next to Analysis tool pack and click OK. The Analysis tool pack is there in the ribbon of the Data tab. The exact name on the ribbon is Data Analysis. Already you have entered the data in Excel. Click Data Analysis button. It opens Data Analysis window. A number of statistical tools are there in the list box. Choose ANOVA single factor. Click OK. It opens ANOVA single factor dialog box. There is a text box with upward facing arrow at its right end. Its caption is Input Range. To input the range of data, first click the Input Data Range text box. Then click at the left top cell of the table and then by pressing the mouse button, drag it to the right bottom corner of the cell. The data range is entered, or you can enter manually also by entering the cell address as C9 colon E13. Then choose the radio button column for group by, because each sample values are entered in the respective columns. Since we have header for each column, tick the checkbox label in the first row. Alpha is the significance level. We are asked to test the hypothesis at 0.05 level. Already it is there by default, otherwise change it. For the output option, if you want to have the result in a new book, choose the radio button New Workbook. If you want to have the result in a new worksheet, choose the radio button for New Worksheet. If you want to have the result in the same worksheet, choose the radio button for the output range. In our case, we shall have the result in the same worksheet. Then choose the radio button for output range. Click the text box and then click a cell where you want the result to appear. Yes, you have successfully generated the result. What next is understanding and interpreting the result. Excel gave the results in two tables. In the summary table, Excel gives the group names, number of observations in a sample, sum of each series, average of each series, and variance of each series. This is only a summary. Now look at the ANOVA table. In the first column, Excel identifies two sources of variation. They are between groups, within groups. These two sources together called total. All these three items are displayed in the first column. In the second column, Excel displays the sum of squares. Sum of squares between group is 72. Sum of squares within groups is 15. Sum of squares of total is 87. This variation 87 is distributed among the other two sources. In the third column, Excel presents degrees of freedom of between groups, within groups, and total. They are respectively 2, 9, and 11. Excel shows the mean squares of both the groups. They are 36, 1.666667. In the fourth column, Excel shows the calculated F value. It is 21.6. In the fifth column, Excel displays the P value. It is 0.000367. It is the calculated P value for the corresponding calculated F value, 21.6. You can compare this P value 0.000367 with the significance level 0.05, which is otherwise known as alpha, or given P value to test the hypothesis. In our case, since calculated P value is less than the significance level, the null hypothesis is rejected. In the last column, Excel displays the F critical value, which is the same as F table value. It is 4.256495. From the values given in the ANOVA table, we know the calculated F value, it is 21.7, and the table F value, it is 4.256495. Our conclusion is that since calculated F value is greater than the table F value, null hypothesis is rejected. With this, we have come to the end of our lesson. We shall meet with the Tamil version of the same lesson in the next video.